Hey everyone, from chapter 4 Combinatorics, I already discussed basic of counting, permutation and combinations, binomial coefficient and identities, the pigeonhole principle, inclusion exclusion, recurrence relation. Next I will discuss generating functions. So what is generating function? Definition 1. The generating function for the sequence A0, A1, ak and its continue of real numbers is the infinite series g of x equals to a0 plus a1x plus ak x power k plus continue. Okay, this is a infinite sequence equals to summation of k equals to 0 to infinite ak x power k. This is our generating sequence. Okay, so gx generating function equals to this sequence, and that we can represent as sum of k equals to 0 to infinite a of k x power k. Let's see one example. Example 1. The generating function for the sequence ak with ak equals to 3. So in place of this ak, we'll write 3 equals to summation of k equals to 0 to infinite 3 x power k. In place of ak, we just write 3. And when ak equals to k plus 1, the value is summation of k equals to 0 to infinite k plus 1 x power k. In place of ak, we write k plus 1. When ak equals to 2 power k, it's equals to summation of k equals to 0 to infinite 2 power k x power k. Here this generating function is for infinite sequence. We can also write generating function for finite sequence. After ak, whatever we can equals to 0, right? So a0, a1 till an, that is a finite sequence. We can consider an plus 1 equals to 0, an plus 2 equals to 0. Means after this whatever all are 0. So g of x equals to a0 plus a1x plus a2x square plus a3x cube till an x power n. This is a finite sequence where this is a infinite sequence. So generative function we can use for both finite and infinite sequence. Next example 2, it's for a finite sequence. What is generating function for the sequence 1 1 1 1 1 1? So these are the ak value. Ak value are given and we need to write the generative function for this. Okay, so 1 plus x square plus x cube plus x4 plus x power 5. a0 equals to 1, a1 equals to 1, a2 equals to 1, a3 equals to 1, a4 equals to 1, a5 equals to 1. So what will be sum of this? We know the GP summation, geometric progression, that by summation rule sum of j equals to 0 to n a r power j equals to a r power n plus 1 minus a divide r minus 1 when r not equals to 1, and it is n plus 1 multiplied a if r equals to 1. Here what is a and what is r? Here a equals to 1 and r equals to x. Every time we are multiplying x. So 1 multiplied x, then x multiplied x square multiplied x cube, like this. Okay, so here a equals to 1, r equals to x. So 1 multiplied x power n plus 1. What is n here? N equals to 5. So n plus 1, it will be 6 minus 1 divide x minus 1. So it's x power 6 minus 1 divide x minus 1, right? So 1 plus x square plus x cube plus x power 4 plus x power 5 equals to x power 6 minus 1 divide x minus 1. So like this, if there is a sequence like 1 plus x square till x power n, then what will be its value? It will be x power n plus 1 minus 1 divide x minus 1. Okay, so here it is till 5, that's why x power 6 minus 1 divide x minus 1. Simply we are using the geometric progression summation formula. Next example 3, let m be a positive integer, let ak equals to cmk, combination of mk for k equals to 0, 1, 2 till m. What is the generating function for the sequence a0, a1 till am? Now solution, g of x equals to cm0 plus cm1x plus cm2x square till cmm x power m. And this is same as binomial theorem, so this value equals to 1 plus x power m. 1 plus x power m equals to cm0 plus cm1x plus combination of m2x square till combination of x power m. So this is for 1 plus x power m. What is value for 1 minus x power m? So 1 minus x power m, it will be cm0 minus cm1x plus cm2x square minus cm3x cube, like this, minus 1 power n x power m. We are just multiplying minus 1 power n, then that result is 1 minus x power m. Now sum of finite geometric sequence a plus ar square plus ar cube a r power n minus 1 is a multiplied by 1 minus r power n divide 1 minus r, or you can write a r power n minus 1 divide r minus 1. This is for finite sequence. If infinite sequence, then that is a divide 1 minus r. These are the geometric sequence, finite and infinite sequence sum. We'll use these formulas, right? Next, example 4, f of x equals to 1 divide 1 minus x is the generative function for the sequence 1, 1, 1, 1, continue. So these are the ak value that all are 1, because 1 divide 1 minus x equals to 1 plus x square up to infinite. So 1 divide 1 minus x equals to 1 plus x square plus infinite. So here what is a? A is 1. What is r? R is x. So this result is 1 divide 1 minus r. R is x. If it will be finite, then it will be x's power n plus 1 minus 1 divide x minus 1. If it is finite, there are n terms. If it is infinite, then 1 divide 1 minus x. Next, example 5, the function f of x equals to 1 divide 1 minus ax is the generative function of the sequence 1 a square, a cube. Now this is our sequence, right? So here what is a equals to 1, and what is r? R equals to ax. Every time we are multiplying with the ax. This is our geometric sequence, okay? So sum will be a divide 1 minus r. So 1 divide 1 minus ax. It's simple. We are just using the geometric sequence summation formula. Next, theorem 1, let f of x equals to sum of k equals to 0 to infinite a k x power k and g x equals to sum of k equals to 0 to infinite b k x power k. Then what will be addition and multiplication of f of x and g of x. Now f of x plus g of x will be sum of k equals to 0 to infinite a k plus b k x power k. So from these two summation, we took x power k as common. So a k plus b k, and f of x multiplication g of x equals to sum of k equals to 0 to infinite, then sum of j equals to 0 to k. We took another variable j, a j b k minus j x power k. Okay, so in case of multiplication, if g of x is inside, then we are splitting. Okay, so g of x, that was k equals to 0 to infinite, in place of k equals to 0 to infinite, we write j equals to 0 to k. Then f of x, that is from k equals to 0 to infinite. So remember this f of x plus g of x and f of x multiplication g of x, will use this formula during example. In today's lecture, I discussed what is generating function, some examples of generating function. In next lecture, I will discuss some more examples and theorems of generating function. If this lecture is helpful for you, please like, share and subscribe. Thank you. Bye bye.